Let's get started, Carlos. I'd like to welcome everyone to this webinar hosted jointly by Simscale and Zaha Hadid Architects. My name is Dr. Nagman Khan. The topic of today's webinar is Early Stage Design Simulation for Architects with Zaha Hadid. I'm delighted to welcome all of you to this webinar, and I'd like to give a special welcome to our guest, Carlos Bausa Martinez from Zaha Hadid Architects. Carlos, how are you?
Hi, Naman. How are you?
I'm good, thanks. Thank you so much for joining us. Carlos, there's been a lot of excitement and interest in this webinar, and everyone's very keen to hear your thoughts and your views around simulation for architects and sustainability in general. And I'm keen to crack on with the topics. Before we jump into that, Carlos, tell us a bit about these interesting times we live in, and we're always keen to hear from our customers and people out there who are working in the industry. What's the market like right now? What are you seeing? How are you guys busy? How's work coming along?
Yeah, we have been like really busy besides all this pandemic situation. We're kind of happy and lucky that we got lots of projects, and we are working a lot with all the simulation linked to everything that is related with computational design. So we're having like a great time and doing lots of research and applied research. So quite good in general.
Fantastic. Okay, I'm really excited to crack on with this. Carlos, a very special thank you. I know you've started your Christmas holidays already, so a double thank you, and I really appreciate you joining us on your day off effectively. Let's crack on. So my name is Dr. Nagman Khan. I'm part of the business development team here at Simscale. I've been here just over a year, and I have a background in simulation. And Simscale, we are a German software company headquartered in Munich, and we have people all over the world. I myself am based here in London in the UK, and what we've done is created the world's first cloud-based engineering simulation platform. So what does that mean? We've created a platform for CFD, FEA, thermal simulation on the cloud. That means these otherwise complex and difficult to use tools are now accessible on a web browser and accessible to everyone. And really excited to say that we have hundreds of thousands of users globally of Simscale from our community plan, which is the free version, but also our commercial customers. One of them is Zaha Hadid, and I'm delighted to introduce our customer and also friend, Carlos Bausa Martinez. Carlos, please tell us a bit about yourself, your background. How did you come about being at Zaha Hadid in this field, this industry? What kind of things are you doing at Zaha Hadid?
Oh, so thank you, Napan. Well, yeah, as I was saying, I'm a sustainability team lead here in Zaha Hadid. And this is like because we decided to open like a new division internally. Besides the fact that Zaha has been working externally with consultants to do simulation and sustainability, we're thinking that it would be really important to have like a team that could do this thing in-house to start very early, tackling all these, demands of nowadays sustainability, necessity. So we're thinking that it was important to have architects, especially, that could be trained on all the computational methods that the company is quite good at to create like strategies that could be aligned with the complexity of the geometries that we are using. So like it's something that we have been doing like that thing. Well, I will show you later this thing more in detail. But yeah, the team is quite early days, so we think that in the future, this thing will be like implemented at a larger scale in the office. So we'll be able to work in all the projects in parallel.
Great. And Carlos, what's your background? How did you come into environmental simulation and sustainability? What were you doing before Zaha Hadid?
Well, my background, I'm a trained architect, so but I decided to focus on everything that is related to sustainability and environmental simulation. I thought it's quite important that in the future, all architects, they will need to look at this, because like I think like the architect of the future will be the architect that is like a person that knows everything about simulation, so they can deliver not only beautiful geometries, but geometries that are meaningful, have like meaningful and reduce impact on the environment. So I started working in Foster & Partners in the specialist modeling group, and then I was working there as an environmental design analyst. And then from there, and from my previous master, I was kind of developing more in depth all these technologies and techniques to get an understanding on what's the impact that a building will have once it's built. So
fantastic, really great to have you with us, Carlos. Carlos, tell us a little bit more about Zaha Hadid.
Well, Zaha Hadid has been working for many years already. We started in 1979, so way before I arrived here, obviously. But this company has been doing incredibly well in the market of complex geometries, architectures. And there's like 450 staff right now working in the office all around the world. And we have people from all different locations, and in total, as you can see here, it's like 15 nationalities here in the company. So it's quite like a varied company with many different people, many different backgrounds, and lots of successful stories and very interesting projects, as you would know.
Yeah, absolutely. Very definitely very well known internationally, Zaha Hadid Architects. And tell us a bit more about what you do.
Well, here, as you would know, we are kind of famous for not doing like a standard architecture. So it's like a lot of teams here and people that has been able to, like expand the limits of architecture to areas that nobody thought it would be possible. So it's like lots of dynamic, innovative architecture being developed here with really advanced computational design methods. And the good thing is that this is possible because we have like great teams and great people doing lots of research on what could be developed in terms of geometry that can be built, so we can get like this type of avant-garde designs that you have seen already. So at the moment, the company has a big portfolio. It's more than 40 buildings already built in 24 countries. And there are more things to come. So hopefully in the few years, you will see that the portfolio will expand a lot with very interesting proposals.
Brilliant, brilliant. And if anyone's curious about this very interesting looking building on the left-hand side here, this image, this is the case study we're going to be talking about later. So stay tuned. I'm really curious as well to hear how Carlos simulated this building. So we'll test Carlos later on. Thank you, Carlos. So today's application is on early stage design simulation. What does that mean? So we're here specifically talking about how computational fluid dynamics on the cloud can be used for early stage design simulation by architects and designers. This is a really interesting topic. We're getting a lot more interest in this, not just from architects, designers, but from lots of different professions as well. So what we're going to do is let's hear from Zaha Hadid first, from Carlos, about how they implement the sustainability team and simulation in their organization. And then we'll take a look at this case study, which was the Oppo headquarters in Shenzhen, China. That was a project Carlos worked on himself. And then I do want to discuss some trends in building simulation that we're seeing. And these are things that both Carlos and I have contributed to. And we're really interested in hearing your thoughts and questions. So in the GoToWebinar platform that we're using, there is a section on submitting questions. Please feel free to start submitting your questions from now. Encourage you to do so. It doesn't have to be questions, it could be thoughts, it can be comments as well. And we'll try and take some during the webinar, but we'll get through to most of them towards the end. And all the images you're seeing are outputs from the Simscale platform as well. Okay, let's jump into this. So sustainability and simulation at Zaha Hadid Architects. How they ensure sustainable solutions on the myriad of projects they've worked on globally and they're working on now. Carlos, please talk us through some of these things, and let's see what's really going on here at Zaha Hadid.
Sure. Thank you, Nachman. Well, as I was saying, before the sustainability team kind of appear here, the company has been working a lot with external experts and consultants and people already in the business of sustainability to be able to deliver efficient buildings and efficient solutions. But as I said, we thought it was important to start very early to do this kind of assessments, and also to have people on in-house that could have the training of at the same level in terms of geometry, visualization, and all the computational stuff that we are developing here, but also that could connect that thing to the sustainability area. And the reason why is because I think that the earliest you start doing this thing, the more chances you will have to have like a more efficient building, and until you can even meet like a net zero building in the future. So we follow like basically what we do normally is like looking at sustainability certificates that they're kind of well established already in the industry. I think that you all have seen there are like many different options for international certificates like LEED, BREEAM, NAVERS, or depending on where you're going, you wouldn't even find like specific requirements or specific standards in each country. So we normally what we do, we just develop like bespoke strategies for each one of these projects. We do it in-house, and now with the capabilities that we have, we started to do it. But before we were doing that thing with our engineers. And what we were kind of thinking, it was like, the sooner you start with that thing, the more chances you will have to facilitate the next steps. Once you go, I mean, if you start early in the design, and you don't look at these things, you can find problems. And later on, if you have someone that basically receives your design and start looking at it from the point of view of the sustainability, maybe a consultant can struggle a little bit to make it work, because sometimes certain things will require changes in the design. So the earlier you brief your architects, this is going to be like much better, because the architects will be aware of the impact that the solutions are going to have in the environment. So we do all these type of assessments. I mean, here's just very like a basic diagram of all the things that we are doing, but definitely we look at every single bit that can have an impact on the sustainability, from the environment where the building is going to be located. We also look at comfort, and then we look at energy consumption and the resources that the building is going to be consuming. So we're kind of thinking that this is very important to have it connected to all the geometry process. And obviously, Simscale comes into the game at the area of pedestrian wind comfort and thermal comfort and everything that's related to the wind analysis that we normally perform.
And Carlos, do you do this kind of sustainability analysis on all projects, or does it vary from project to project or size of project?
Well, this is something that we do we deliver this for all the projects. Internally, we do it with the sustainability team for some of the key projects. But at the end of the day, it's like this team has been it's early days for this team to deliver the same status for all of them. But what we do, we just deal with the external consultants to ensure that everybody is kind of delivering exactly the same things for each one of the projects. So some of them we tackle them ourselves. So we have a team right now with like different experts in different fields. Even myself, I'm doing simulation at the same time that I'm managing this team. So because we are kind of small, we need to really be multitasking all the time. So but that's something that's, even when we are not able to do it ourselves, we help the other teams to liaise with their consultants, and we kind of explain them what's better from the point of view of each one of the projects. And we ask them certain things that are basically aligned with the projects and the nature of each one of the projects. It's quite interesting and quite time-consuming process. Yeah, it's got like a lot of energy there.
I'm sure. Yeah, I mean, there's some really interesting types of analysis here on this slide, and the fact that you do these types of analysis in one team is great. What kind of skills does a team need? Do you have people with a background in environmental modeling, or are there architects doing this type of simulation?
But normally the things that we have been looking at right now is like architects that are specialized on computational design. So they at least need to know visual programming, and people that is like also trained on environmental simulation. So we are looking at these profiles nowadays because we think that the balance is in between a person that is very good at design and a person that is very good at environmental modeling. Because if you merge these two together, you will be able to have people that is already informed on the decisions because they know, all the process, all the steps of the process.
Great point here, and it speaks to the kind of tool you're using as well. How easy does a tool make to combine different design variations with simulation? And we'll talk more about that. Thank you, Carlos. Shall we move on to the next slide?
Sure. Yeah.
Great. What's going on here, Carlos?
So here the things like, I mean, when you're looking at all these strategies that you need to take into account, like sustainability is a broad topic. So, and people sometimes is confused on the way that analysis is applied and how this is kind of affecting the sustainability conversation. So what we need to do first, like obviously establish like a kind of like comprehensive strategy for like sustainability strategy that is taking all into account all these points that I mentioned earlier. But in order to reinforce your proposal and also to ensure that these elements that you're going to have at this point in your strategy, you need to have simulation. And basically simulations will help us to really enforce the accomplishment of all these things that we have been, like thinking before in the strategies. So like, if you think about it, like you cannot talk about sustainability by just making a diagram. You just need to explain to your juries or to the client or to whoever is your audience that actually what you're proposing is going to work. So that's where we found out that obviously we need to work with all the companies like you, like Simscale, or like other companies that are doing simulation tools to really try to put together like like workflows that can serve our projects, but at the same time can help us to deliver, to meet the requirements of the sustainability standards for each one of the locations. And in that case, the wind flow analysis and Simscale was quite successful at that to serve this area of analysis that we need. So all the other here that you can see that basically we look at comfort and energy as the main drivers of our strategies to ensure that not only the occupants and the people living inside of the buildings or using the buildings regularly are going to feel with the right conditions, they're going to be okay, they're going to feel comfortable. But also we look at the energy of the building. We want to ensure that the energy at the end of the day is like consumed efficiently and responsively. So because if you have a building that you don't think about the implications, how the geometry, for example, is going to impact the energy consumption based on the climate, then probably you will have problems in the future. And also you are not doing much. You should do like a lot of effort to really make that thing work. And that's where simulation helps us a lot to really deliver an understanding and also to brief the client and brief our teams on the impact that its solution is going to have. So here, I mean, like just to talk briefly, is like we do climate and everything that is related to the atmospheric conditions, how they are going to impact the building. That's where the wind comes, that's where the annual exposure or energy or even thermal comfort are going to have a, like a word here. And we ensure that the geometries are going to be efficient enough to deal with all these topics, like in a way that they're going to deliver what we're expecting, what we are supposed to do according to those certificates. On the other side, I mean, like the experts that we have, they are in control of tools like Ladybug and Honeybee, that is basically visual programming tools. That basically there's an interface to other engineering tools like Energy Plus or Radiance that are going to do the calculations and the numbers behind that thing. But the good thing is that all these tools together can be connected to the geometry. So this way we can optimize geometries and deliver more efficient buildings.
Absolutely. And you made some really interesting points there. And Carlos, we've already discussed the API that Simscale has and the link with Grasshopper. I know you're keen to try that. How important is it having a tool that can connect to multiple other tools? Because we don't have a one tool fits all. No one tool can do everything. So I guess the ecosystem of tools you use is really important, isn't it?
Yeah, exactly. As you said, we spend lots of time talking to developers to really get the tools working in the direction that we need. Because as you know, I mean, like each office has a different kind of approach to the architectural business or to the design. So particularly in our case, since everything is so complex in terms of geometry, we really need to have like workflows that are like able to serve this complexity. So I think like having API open to access that thing and create tools and create connections with these other tools, or even to customize the portal or the tool itself, that helps us a lot. Because at the end of the day, an engineer, two different engineers will use the tool in a different way, depending on the industry that they are working for. As we are architects, so we are not directly doing the engineering, but it's very important to understand early, all the implications of your building design. So that's why we normally like tools that we can just strip out things that we are sure that we're not going to use, because I think we're not doing heat dissipation and we're not working in the electronics, but we know Simscale is able to do it. So we need to look at the tools that we are going to use, and it's great that you guys have that thing so we can customize it and make something meaningful for us.
Absolutely, and thermal comfort is a whole nother discipline. And one of the great things about Simscale is we've used the external aerodynamics, the wind flow around buildings to calculate wind pressure coefficients and import them into thermal modeling software. So third-party modeling software, which increases the accuracy of the simulation much higher. So that's great. Carlos, I have a question here from one of the attendees, if you don't mind taking it right now. It's from Claire, who we know very well. Claire's an expert in simulation, and Claire's asking, do you get involved with the buildings at all once they're kind of designed, handed over? Do you have any feedback from operational performance feeding back into your designs, either for energy or for comfort, or anything like that?
Sure. Yeah, that's something that normally we want to request to get that thing in the future, because right now we are working at the scale of design, and the division in the future, that's something that we need to tackle, because definitely to get feedback on the building is quite crucial. I mean, we know that through the consultant side, we know they are doing it, and some of them they already improved certain workflows thanks to the feedback. And basically, they were informing us on all these things. I mean, now that we have that thing in-house, we are hoping that in the future we'll be able to get all this information directly from the building, so we can adjust, or we can also understand how the performance and the possible variations that our simulations could have. But yeah, that's crucial, and I really know well this process, and I'm hoping that in the future we'll be able to do it so we can have it efficiently applied on the whole workflow that we're developing now in the office.
Great. Carlos, I just want to pick up a point there. I think it's the second bullet point when you talk about computation and power to handle analysis, right? Simulation workstations. Obviously, with the cloud, you don't really need to invest in too much hardware. What's the benefit of the cloud? Have you noticed the benefit that you don't need to do? It's one less thing to do on a workstation, which might already be overloaded with lots of other different types of visualization software.
Yeah, I mean, that's a very good point. Yeah, it's great that you guys have this thing on the tool, and that's what we basically look at Simscale, because you guys have that thing in the cloud. I mean, knowing the industry of CFD from my previous experience, I know that you need massive computing power to do it if you want to do that thing in house. So, but that's something that is not at the reach of many companies. So I think all the medium or even the small companies that want to do CFD, they really need to look at this from the cloud perspective, because unless you have classes of computers together working in your office, that's quite expensive. It's going to be very hard that you're going to be able to deliver, accurate simulations. I mean, you can test all the tools that you will find online, but definitely you need power. I mean, obviously, from the point of view of CFD, definitely the cloud services, they really help us a lot. We hope that in the future, all the energy modeling and the rest of the software also can migrate to the cloud. So that will help us to have everything run even from a laptop. I'm hoping in the future this is going to happen. I feel at the moment when you need to work with energy, or when you need to work with daylight or anything that's kind of based on other tools, you really need to have a powerful computer, because as soon as you want to throw the whole geometry inside of the simulation, that's going to request lots of power. And also for visualization purposes, you need the computer that is powerful enough to do it. But yeah, definitely we are very happy that you guys have it, and that's one of the main reasons we decided to go ahead with you.
Fantastic. One quick question from Parna was asking about the LBM solver and the benefit of using PwC. So I recommend everyone take a look at the Simscale website, which talks a bit more about the lattice Boltzmann method solver, which is integrated into Simscale. And we have an automated tool that takes you through step by step the pedestrian wind comfort study. So the great thing about the LBM solver is it's fully transient, so you're modeling a real wind, and because it runs on GPUs and it's on the cloud, and just the way it's designed and optimized to make most use of parallel simulations, it's incredibly fast. It's an order of magnitude faster running transient simulations, and the post-processing obviously gives you really great animations and the quantitative data as well. So we can look more at that later on. Let's crack on, Carlos. That was really good. Thank you. Okay, so I guess so how have you been using Simscale, I guess is the next question. What for specifically? How was it implemented at Zaha Hadid?
Yeah, well, mainly we have been looking at three things. It's like wind comfort for outdoor spaces and also for terraces and bits of the building that can relate to public space. That's one of the main things that we have been focusing on to really understand how it's going to have an impact, the building geometry and the surrounding into the public spaces. So thermal comfort is something that also we have been looking at, and for different kind of understandings of the energy that we are going to need to really make a space comfortable or not, or the mitigation studies that we need to apply in our buildings. So also the passive window ventilation is something that we found that was quite relevant, because sometimes we develop like really large buildings with atriums inside, and having an understanding on how the air is going to move in the interiors and how it's going to affect the people, we found it quite crucial to have that thing there. So our team has been kind of looking at these things for various different projects in different stages.
Yeah.
So we normally crack on with this thing at the very beginning. For competitions, we just deliver certain basic studies. And later on, as soon as we have won the competition, we just start looking at that thing at the SD stages with a little bit more depth or more details, or we just go to specific simulations in certain areas. So and also like the good thing of that thing, of these simulations kind of give us, because it's in the cloud, we can get results quite fast. So we just wait for maybe 1 hour, half an hour, we get the submission, we get the results, we check them, and if we need to make any change, we can do it in the same day. Like before, when I was looking at people working in simulation on CFD, I could see these people like spending days waiting for a result, and that was kind of like making things are very, very slow to take decisions. Yeah. So now it's something that you can, if there is an architect that comes to you with the geometry in the morning, you can just in 1 hour or 2 get the building ready for the simulation, get the results, send it lunchtime. So after lunch, you can just get the results and get again changes and go through another process of changes according to the first results. So in 1 day, we can get an optimization ready. So that's quite remarkable. That's from a software. So,
Absolutely. You just hit the key points there. Running fast simulations on the cloud using a tool which has a solver like LBM built into it gives you that ability to run multiple design variations for a transient analysis, like the one we can see on screen. Like you said, exactly on a day, and that helps with the the teamwork, the design ideas. Historically, people think of CFD as something that's difficult to do, it's time consuming. It costs a lot of money, and it has been. These are all based on truths. These perceptions of CFD. Some of the people who've been using CFD for a long time. We can remember waiting a weekend for something to solve, right? Or leaving it overnight for 3 days, for example. So thank you, Carlos, for highlighting that point. So it's great to see you guys are doing kind of wind comfort studies, thermal comfort, indoor ventilation. Really important, and analysis to inform design at multiple stages. And the great thing about the speed of Simscale, again, like you said, at the competition stage, where you quickly want to just get through some design variations without going into too much detail, lends itself to that really well. So Carlos, what's happening here on screen here? So you've run a quick analysis. There's a transient simulation here. We can see an animation of areas of high winds, calm areas in and around your buildings. How would you use this? Would the next step be then you can change the layout of the building, maybe add some trees using the porous media feature, see what impact vegetation and the streetscape has? Is this the kind of typical workflow you go through?
For wind comfort, definitely that's the aim. So we use it just to map out the areas that we know that are going to be like problematic because of the winds and the wind loads. And also we normally do what we like of that thing is that you can use all the weather information that is locally available. So it's not that you need to set up yourself the whole simulation following a complex process. You just get the data from the specific location using MeteoBlue, and then you get like a very quick understanding on the areas that are going to be affected by strong winds and the areas that are going to be protected. And when we see something like that, we help architects to understand what they can do, because normally they have a program, they need to allocate certain uses, and they need to specify where these things are going to be located. And you suddenly get a reading that in an area where you were expecting to have a terrace or something, you get like winds around 36 kilometers per hour or 40 kilometers per hour. There's going to be a very uncomfortable place to be, and then from there we open conversations so we can help them to understand that they need to place solutions on those locations. And also is on the other side, if you're in a hot space or in a specific moment of the year that's expected to be hot and you want to improve it, obviously we're going to try to facilitate some kind of wind flow around these areas to improve the benefit of having local winds. That is, at the end of the day, something that is going to be like a passive strategy. So you minimize energy that you would need if you have, like, I don't know, specific cooling systems or outdoor systems that can help you for that.
Absolutely.
So that's actually the aim of this image right now. It was just to basically map out the space, get an idea of the areas, and then from there establish like a comprehensible landscape strategy that could be in tune and help to solve problems, rather than being only a decorative feature. It's like having trees or having shelters is something that you can do quickly with this tool. At least to understand where you're going to have them. So.
Exactly. Thank you, Carlos. We have a couple of questions talking about validation. So Simscale has dozens, if not more, studies and documentation resources published on our website. We have a huge section on validation of the Simscale software and how we've compared that to wind tunnel testing and also other commercial CFD codes. So please do check that out, and we can include a link to that in the follow-up email we send after this webinar. Carlos, let's move on. Great. And just recapping some of the benefits to you and your team of using Simscale.
I think that's the main thing is we're architects. First of all, that's why we want this tool to be like a tool that we can easily use. So it's kind of what we like of that thing is we manage to train people very quickly on the understanding on how to run the tools, how to get the simulation, and how to get results out of that thing. So, I mean, the people that we get trained, they are not engineers. They don't have a CFD background or, I don't know, aerospace engineering background. So we found quite interesting that we can get results. And also, the good thing is that we have engineers that support our decisions, obviously. It's not that we're just doing that thing totally solo freestyle. We just normally validate things with our engineers that are supporting us over the process of the design, that are basically those with these abilities to really sign off the projects and say, yeah, this is working. But since we're using that thing early stages, later on for them, it's way easier to really validate that these things are going to work. Because as soon as you have tested something against these tools, you can really understand if it's going to work or not. In 90% of the cases, it works. And then we can see that the solution of the simulation, we can reduce it so we can get results faster. And later on, as soon as the engineer is going to pick up that thing, he is going to realize that, what we did at the beginning, because we used some tools to really orient our thoughts, it has a better impact at the end of the day. So the benefit of doing it and not doing it is a lot, because if you have, for example, a team that who didn't work on these simulations, when the engineers take over, they realize that it's harder to change things because maybe they didn't thought about the consequences of the design. And that's something that really allows us to go faster on this process of iterations and changes, until we get something that is fully validated by the commission engineer that's assigned for the project. And that helps us a lot. That's something that save us time, save us money, and save us upsetting people, because when things are not working as you expected, then suddenly you get a lot of angry people that say well, why is this not working? So you didn't thought about it at the beginning.
That's right.
Now we just basically escape from that process, and now all the people that we work with, they're very happy to see that these results are something that they can have on the first week they are starting to think about the project. And also comparing the performance comparative solutions is something that we do almost every project. We need to develop I don't know, 15 options, 30 options. They want all of them validated. Sometimes we just, take some of them that we know that they're going to be the main ones. But before, it was impossible to think about validating 15 options in less than, 3 months. So it's kind of now you can validate 15 options in 2 weeks. You have 2 or 3 guys working on that thing all day long, and definitely they get the results quickly. So before, it was impossible to think about it. And now. It was interesting because at the beginning we were thinking, we're going to save time, but suddenly, because you do things faster, you have people asking you for more changes and more modifications. That's good because it helps you.
The expectation goes up. That's right. The expectation goes up. Absolutely.
Exactly. Expectations.
Yeah, Carlos, listen, I can't keep up with the questions coming in,
Oh
so
my
it's
God.
great. There's a lot of interest. So let's wrap up the slides so we can take more questions towards the end. But quick
Sure.
question, quick question from me to you. Your first point there is easy to use by architects. As an architect, how long did it take you to learn how to use Simscale?
Well, I mean, like, since you guys trained me on that thing, it took me like a week to catch up to understand the whole process. But after the first week, I was feeling comfortable doing the simulations. I mean,
Yeah,
previously I have some background and understanding on the topic, but the people that we have been training here, they start like producing things very fast, and we
yeah,
like it.
yeah,
So we like to see
yeah,
that the resolution is enough for the purpose that we are doing. We are not
yeah,
doing Formula One cars here. Obviously, whoever's in the industry, we know
yeah,
that this process is
yeah,
way more complex and has
yeah.
lots of things to take into account. But for architects on early stages, I think it's quite important, and at the level that we need. So.
Amazing, thank you. I'm really looking forward to hearing about this project, Carlos. The Oppo headquarters in Shenzhen, China. I'd let you talk through the next couple of slides, and then we'll have a quick look at trends in building simulation. And I'm keen to get to the questions. There's a ton of questions coming in. Carlos, please tell us about the Oppo headquarters.
Well, I think you guys, you have been like reading the news. You have seen this building around. Has been for some time already in the media. This Oppo is like basically like a mobile phone company. It's like a telecom company, and they decided to go ahead with our proposal for the headquarters. So we won the competition, and it's quite like an interesting building. It's like 200 meters tall building and 185,000 square meters. So it's lots of things to do inside and outside of analysis. So here we are just showing only a little bit on the area of simulation for wind, but definitely there was like lots of simulation behind to validate different things and propose different solutions. I think in the future you will see like certain different things in the building, but in general it was quite an interesting starting project. That's actually one of the projects I started with when they were already designing this thing. So we started looking at the simulation before even having the whole team set up. But the thing is that it has like lots of offices inside. So basically it's an office building for the headquarters of this company, and underneath on the plinth of the building you have like commercial centers and lot of leisure spaces for the public. So also the landscape, it was quite interesting landscape because it was like part of the proposal. And then we had to work, all at different scales here from different perspectives. From the comfort perspective was one of the main drivers. So we wanted to design something that would be, useful for the people, even for the pedestrians that are outside that can enjoy the surrounding space of the building, not only for those working inside of the building, but also for those outside of the building. And that's where we started actually to work on the CFD tool that you guys have on Simscale. We started to apply that thing with this project. And I think you can go to the next slide so we can see. So the good thing of that thing, of the process, the workflow that we started with you guys is that it's very easy to import the geometry. So it's not that complicated. You don't need to have like a totally airtight building. So you can have like geometries that are kind of separated from each other, that can be like overlapping. So we found like quite beneficial the fact that you can do this process very fast. Because I mean, I remember my friends working in the CFD area. I remember them spending crazy hours to really create an airtight model in one single piece that was suitable for the wind tunnel analysis. I remember that like struggling and complaining a lot, because I was like, when you have an architect team, they design very fast, so they can get very quick visuals, so they can convince themselves and the client or whoever is the audience that they're working for about the output of the buildings, So you basically cannot stop them or prevent them from doing what they're doing and the way they're doing it, because then you will basically clash with their workflow. I will slow down the process. So we found out that it was easier for us to use this software because also was helping us to reduce timing on preparing the geometry and just making an STL or OBJ file. It was something that's straightforward in the software tool. So, and then as you can see here, it's like as soon as you have the building there, it's very quick to find the location of the building and set up the wind conditions for the simulation. And just, I mean, that's like, these are the benefits that we found, like all the quick preparation process, and also how fast it is to set up this simulation.
And then you hit simulate. Yeah.
Exactly. So
And that's,
when you import
yeah,
until you simulate, that's great, man. Like
yeah.
you are well
And
done.
yeah, absolutely. And this is actually a screenshot of the Simscale interface. And one of the reasons for the quick geometry import is the benefits of the LBM solver itself and the way it solves the physics behind it. It doesn't need a watertight geometry. So you do save days, if not weeks, in terms of geometry cleanup. And then, as Carlos said, we have the weather database integrated here. So you can just type in the city or the postcode and it will import all the weather data for you. And like Carlos said, you just hit simulate and let's see what you get, Carlos.
Yep. I mean, like the thing of getting results of that thing, that's something that we also like. It was the looking. So because I mean, when you are working on the architectural business, we are really picky on the way things look like. So we really need to be careful even on the way you present engineering results or simulation results. And that's something that I request to every member of our team to be specialized in visualization. So that at least they need to know how to do proper renders. Because at the end, you need to talk to an audience that they are not experts in simulation or not even think about simulation at the first moment of the project. So you need to really bring them on a journey with you about what are you doing, why are you doing that thing, and what is going to request afterwards. So here we were kind of doing kind of like a wind comfort test for one specific wind direction. And then obviously for each one of these projects, starting for this project, we develop many different angles. We test all the angles according to the intensity and the frequency of the winds and the speed. We develop like different visuals and we show them what's going to happen in every moment of the year or in every season according to its wind direction. So we can ensure that there are like strategies applied on according to seasonal winds that can change or shift completely from the warmer seasons to the colder seasons. And then from there we can establish like a conversation with the architects and also with the client about what are the needs of this location and what are we going to need to do on the site here. So here for the landscape, for example, we kind of thinking on sheltering options because from other wind directions we're getting like different strengths, and then we were finding out that there were some locations that were having like like more potential problems in terms of strength of winds, and then we decided to do like landscape features that could help us to protect from the strong winds, and from also like it was linked also to shading strategies as well. So that's something that we worked a lot on that thing. Also we did like simulations and videos and transient simulations. So I think like in the next slide here we have it. The transient out was kind of great. It's a great way to communicate with your audience on what's going to happen. Here you can see like the strong winds that I was mentioning. So we're kind of like checking different locations, and basically with the video, it was kind of faster to explain that thing to help them to understand exactly what happens. Because you see like a colorful map, but if you don't understand where the wind is coming from, maybe you don't understand what the colors means. I mean, obviously we explain them. We just explain everybody what's gonna happen and how to read those things. But like the combination of 3D, the animation, the static images all together with our reports, it helped architects a lot to understand what they need to do, how they can improve this. Before wind simulation or before like solar simulation, that was something that it was just only up to architects to guess, based on their personal experience. But now with simulation, now that we have the tools, you really need to apply them because it's easy to get the results.
Absolutely.
You can, if you have people that can help you to interpret those, it's a win-win. It's like the company. Some of the things that we have been doing is training people that they are architects, but they don't have any experience before, because we realize that to make like a building sustainable, it's not only up to few experts to decide what's going to happen with the building, because at the end of the day, who is designing that thing has a different background. And if you have a person that is doing like computational design at a very high level, maybe it's not the person that is so much focused on simulation, and maybe it's a person that also doesn't necessarily need to understand all these things. But we realize that if we train them, even if we train the non-experts, like people from all the different levels, even from people just starters that just arrived to the company, people that they are senior designers, or people that they are just the leaders of the projects, we found out that by training and helping them to understand how to interpret all these graphics, your building at the end wins a lot, because at the end, it's a matter of working as a team. It's not working as individuals.
Yeah.
So like everybody working together to take those decisions. And then with those kind of graphics and these representations of the data and the simulation, you get very quickly understanding how the building is going to behave. So the aerodynamics here were like fantastic, because the building with such a smooth shape, it was like, like the dream of many engineers, because basically there's very little drag in certain locations. You can get like suffering corners that are having lots of pressure. And these things and the simulation help a lot to understand that the building will have kind of like benefit compared to the buildings that are on the surroundings.
That's right. And the building aerodynamics you can pick up with Simscale as well. The 3D slice and the 3D aerodynamics of the building and what impact it has on surrounding buildings, upstream and downstream buildings. In fact, one of the questions we've had is about surrounding buildings. Absolutely. If your 3D model contains surrounding buildings, they their impact will be picked up in Simscale, whether they're upstream or downstream. And that's the great thing. In fact, what we've done is Simscale isn't just used for modeling buildings. We've done entire master plans and city size simulations where you're where you're bringing in a whole city and simulating it for example, wind comfort and wind safety. Fantastic. This is a great project. Carlos, did you do these simulations?
Yeah, man. I was on it. I was like, working at very early. I was like on my own, only doing the simulations, and also for other type of projects, I was also working with other members of the teams that they're also very skillful. And I mean, it was quite surprising to see people working on simulation already. But obviously, you cannot dedicate a person that has been hired for architectural design. You cannot put them to do simulation, because basically they have a different role. So but it was like great to see that when I arrived to this company, that many people already have a background in simulation. And but obviously we decided to hire people specifically for that thing, for this purpose. So we don't bother those doing great design, because I mean, like, people here is really multitasking on many things, and they're very good at very different disciplines.
Absolutely.
But I think it's also crucial to have like some experts that can help you to understand what you're doing, because like simulation is not only about getting colorful stuff. You need to understand that all these values will have an impact, and how can you improve it. It's like also like a whole kind of journey that you need to follow with the designers and the architects.
Absolutely.
But exactly, it's just having everybody kind of trained in the topic is something that for us was kind of like one of the goals, is just to have everybody exactly with the same understanding. But now we managed to train like 1/4 of the company on different simulations, and we're releasing even trainings for them to pick up and catch up on this topic. So it was good.
Brilliant. Carlos, I want to just quickly mention some trends in building design simulation and get your thoughts on it quickly, and then let's jump on to and answer as many questions as we can before we have to wrap up. So there's a few key trends we're seeing, in the industry, in the market globally. And these are things like co-simulation with multiple tools, capturing more physics, collaboration, and having an ecosystem. And what's great is you've touched upon all of these. So you're already doing these at Zaha Hadid, but just for the benefit of people watching. So co-simulation, what does that mean? It means applying physics in CFD to complement thermal modeling tools, for example. So other tools people might use for energy or comfort, for example, they're designed for a very particular thing. But they're not designed to model airflow in detail. And airflow outside the building, inside the building, it has a huge impact on the overall energy performance and comfort performance of a building. So we're seeing a lot more people asking us to do simulations in CFD in Simscale and help them import it into the thermal modeling tools, which is something we can do with Simscale. And because what we're doing there is we're capturing more of the physics and making use of the cloud. Like you said, we're doing these complex simulations on the cloud and then making it easy for people to digest it and absorb it into their third-party software. And a great example was wind pressure coefficients, where you can use CFD to generate those pressure coefficients and then import them into something like Energy Plus or IES or TAS, which don't actually calculate them. And then what we found is, we did a whole webinar on this a few weeks ago, that the accuracy of the thermal modeling simulation increases dramatically if you're using more accurate wind pressure coefficients. So we're also trying to, people want to capture more of the physics, the external environment, coupling that with the indoor environment. Like you said earlier, Carlos, the indoor thermal comfort environment is heavily influenced by what's happening outside, especially where buildings where you have kind of natural ventilation mixed mode. So how to couple these a bit more effectively, So, wind atmospheric changes do have a big impact on your heating and cooling loads, whether that's through ventilation or infiltration. right? So coupling of the external and indoor environment is very important. And then integration and collaboration, right? So Simscale have released an API, and we have a tool ready with linking it with Grasshopper. There's a lot of interest around this. I know, Carlos, you're interested in looking at that as well. So automating the simulation, through a platform and enabling teams like yourself to collaborate, especially, people are working remotely now. Simscale really is a collaboration tool as well. Multiple people can sign into the same project and work on this. But you can also get other stakeholders involved, right? It's not just team members. You can give view access, for example, for a presentation to planners and contractors or other project team members. So Carlos, what are your thoughts on kind of those trends? Is that you're seeing this as well? You're already implementing some of those?
Yeah, definitely. I think collaboration is key here, and also like the way of sharing the results is also very important. I think like the platform is allowing like this kind of great communication with many different stakeholders and people around, and especially for us, because I mean normally we're talking with ourselves about sharing these things, because when you need to really open like a simulation and open the file, you don't need to deal with the mess of dealing with other scripts, because I mean like when you're working on environmental simulation, you need to work with tools that we're using, for example, inside of Grasshopper. There's a kind of visual programming platform. So when you're doing like scripting inside of this platform, it becomes quite a personal scripting environment. You put your things in the way you feel that it works. Obviously we have like some kind of structural basic kind of scripts, and people just kind of write on top of them. Actually, I was like doing that thing at the beginning, just to create like lots of custom tools for people just to take over them and modify them according to the needs of each project or according to the geometrical problems that they have to solve. But what I found out of Simscale is like, well, you just don't have that mess, because everything is a platform. You get all the files, you get all the settings in a menu. Those kind of easy to digest, so nobody needs to deal with your mess in terms of scripting. So absolutely. You can just share it with someone else, open the same kind of session, and they just pick up the same kind of thing that you were working on, but they don't need just anything else than modifying geometry in case they need to do certain changes, and then run it again without like complex processes. So I feel like that's one of the key things, like the workflow is kind of easy to share and easy to get results from.
Carlos, let's do a quick fire round on the questions. Okay, are you ready?
Sure, man.
I'll answer some I'll pass over to you. So a question was about simulation on higher floors for high-rise buildings. So absolutely, you can output the results of the wind comfort, wind safety on roofs, on balconies, doesn't matter how high the building is, and the wind profile variation by height, that's treated very scientifically as well. We have a huge documentation on how that is done. Okay, Carlos, question for you. How many different types of buildings in different countries require the wind comfort analysis or proof of wind comfort? Do you do it on buildings globally? How does it vary? I know some countries have specific requirements, like the City of London wind modeling guide. Other countries, other cities, for their planning purposes, they might be a bit more relaxed about it. What's your experience of that?
Well, it's funny because I'm looking at certain certificates. We're looking, for example, at Saudi Arabia and also China. They are quite kind of like concerned about the comfort that you're going to get outdoors. So you really need to justify with the studies that the proposal that you're doing is going to have a positive impact on the exteriors. So, but in general, we just try to do that thing globally for all the projects, because at the end it doesn't matter if one country is requesting a specific thing or other is not. At the end, you have people and locations. So what you need to do is try to keep these people comfortable wherever they are, independently on which part of the world they are. So we try to serve that thinking rather than saying we are only going to do the analysis for those who have the code that's requesting specifically this type of analysis. So we are thinking that sustainability is a global thinking. Obviously, each country has its own requirements, and they can give you even like its own kind of values and specific kind of requests or demands. But we think that's something you need to request to apply globally in all the projects.
Great. Another quick question on the different types of analysis. Yes, you can have that same model and use it for wind loading, for example, or wind comfort, wind safety. So that's a great thing about Simscale. It's got a similar interface for different types of analysis. Carlos, a question for you is on COVID. So have you been asked, or is there something interesting you're looking at in terms of impact of COVID on things like ventilation or outdoor airflow in and around spaces?
Yes, this is a request that we had, but something that we have done with that thing, because I mean, the team right now is ready to do like certain studies in locations. We just outsource these things because we know that they are quite important. And so we just kind of let that thing on the hands of engineers to really answer those questions specifically about COVID, because the tools that we are implementing right now, they are kind of like serving us in a way to make tests for early stages of the design, but we didn't kind of tackle that thing specifically in the wind area right now. But yeah, I think like the good thing of working with like a broad, like teams of engineers that are kind of consulting us is that you can ask them to do these things because, they have been in the business for a long time. They are the experts doing that thing. So for this kind of things that, we prefer the engineers to tackle.
Great. And Carlos, another quick question from Claire. How do you input surrounding geometry? Do you build it yourself, or do you import it from third-party tools? In Simscale, there's lots of ways to do it. I just want to hear your view on it.
Yeah, normally we do it ourselves from what's provided to us. What it means is like sometimes they give us files, like the teams or the architects or the client itself. Their departments are kind of sharing with us certain kind of material. But what we do is normally we process this kind of material depending on the nature of the geometries. We transform them into something that the tool can, work quickly with. If they come in the format of meshes and they are the kind of low poly, something that also that we can import directly there. If we feel that we need to tackle or just modify something there, we just do it ourselves with our, geometry experts, simplify those, and we just submit that thing. I mean, personally, I spent like many hours doing cleanup of big files. But after some time, we find out, ways around to simplify things with the scripting, basically.
Yeah, great. We have other users who import things from things like, CAD Mapper or Accucities or ViewCity, so that's all easy to do. Someone asked a question about the API and the SDK. It's in C and Python. Get in touch with us. We can share more information with you. User Saba was asking about results. Yes, it will give you pressure and velocity temperatures. It will post-process and create the visualizations for you. There's a question for you, Carlos. Do you work with the code group at Zaha and developing kind of bespoke tools or customizing tools like this? And with the API, what's your plan to kind of test that and roll with it?
Yeah, that's something that we are kind of thinking in the future. We already have worked with them, so we have been like doing like tools. So we have been requesting like certain things, and they're incredibly amazing. So this team is like really have a great expertise on the topic. So right now we are in partnership trying to get like more things for next year working. So for custom tools that people can use at early stages in platforms like Maya or even like Rhino, that doesn't require like really high kind of like expertise on the topics. But I think that it's something that at the end, as a company, you need your customized tools. And it's great to have like someone on board that they are like doing other great projects, but at the same time, they provide this type of services. And I feel like, that's a success, like when you have like such a great team and such a great company, it's great that all these things happen because, everybody is really happy to do it and really willing to go ahead, because at the end of the day, sustainability and all this type of simulation is going to be always with us. And it's not that it's right now it's a trend, but it's like a necessity. So you really need to tackle that thing to be able to deliver, efficient buildings to preserve the world we are living in.
Carlos, listen, we can't get through all the questions. It's great to see so much interest, Carlos, in you joining us. I think we should wrap up there. It's 5 p.m. The hour has flown by, and likewise, we can listen to you for another couple of hours. So thank you everyone for joining us, all the attendees, all the questions you've sent us. Please do get in touch if we haven't managed to answer your questions, and we will have a copy of this recording ready in a few days to share. If you've registered for this event, you will receive a follow-up email, and you'll be able to follow us on the Simscale blog and our YouTube channel and our LinkedIn channel as well. Finally, Carlos, listen, really great once again to have you joining us for this webinar. Thank you for the work you put in for preparing this webinar as well, and we look forward to continue working with yourself, your team, and Zaha Hadid on helping you with design simulation and creating these wonderful projects that you're doing globally. Any final thoughts from yourself, Carlos?
Just saying thank you guys for creating such an amazing tool and for making it easy for architects to really start simulating in the so complicated world of CFD and wind simulation. Because I mean, it's like it's an amazing world. I really respect the people that is working on CFD and wind simulation. And thank you guys. Thank you for hosting me, for organizing this thing. It was great, and we'll be in touch.
Fantastic comment, Carlos, and thank you for ending on such a great point. To yourself and family and everyone watching, have a really good holiday season as well, and we'll be in touch. Thank you. Goodbye.